Okay, so in this on this worksheet, we're graphing a quadratic equation. We're graphing two quadratic equations. So you have y equals x squared minus 6, and then you have y equals 6 minus x squared. Now, these are basic quadratic equations. In another section, you're going to get more complicated quadratic equations where you're going to have to find the vertex, you have to find the x-intercepts, the y-intercepts, and so on. All right, but in this case, you're just being introduced to what does a quadratic equation look like. That's the purpose of this worksheet. What does graph look like? All right, so notice this is a quadratic equation because the the exponent of x squared is 2, so that makes it quadratic. So you have something like y equals ax squared plus bx plus c. Okay. Now in another section, you're going to graph quadratic equations, quadratic functions. We haven't talked about a function as in here. We did it in a previous course, but not in here. So I'm just going to use the word equation. So we talked about quadratic equations before, but in another section, you're going to graph quadratic equations in which you are going to have an x term. See here, there's no x term. There's an x squared and a constant, but there's no x term. And you're going to graph quadratic equations where the coefficient of x squared is going to be something other than 1. Here, the coefficient of x squared is 1. Same thing here. Coefficient of x squared is a negative 1 here. All right. Now you're going to notice that I'm going to talk about this in another section, but for right now, you're going to notice that see how the x squared term, the coefficient is positive, and over here, the x squared term, the coefficient is negative. So when we get to that section where you're going to have to graph quadratic functions, we're going to come back and we're going to talk about, well, what does that positive and negative coefficient of x squared do to the graph? All right, but all we're doing here is all you're doing here. The purpose of this is just for you to see what the shape of a quadratic equation looks like. So the points are already given. You're gonna see the same thing in my math lab. The points are already given, and the points are already given for x. The coordinates for x are already given. You just got to find the y coordinate for that corresponding x coordinate. So if x is 0, again, just like we did before, you're going to just substitute the value of x into the equation. So when x is 0, I get y equals 0 squared minus 6. And then remember, order of operations, you can do exponents before you subtract. So 0 squared is 0. 0 minus 6 is a negative 6. So I'll plot the point 0, negative 6. Okay, so there's the point 0, negative 6. Now, the directions don't say anything about labeling, so if you just plot the point, you're good. Next one, x is 1. So I get y equals 1 squared minus 6. Well, 1 squared means 1 times 1, so that's 1. 1 minus 6 is a negative 5. So I plot the point 1, negative 5. So you go to the restore the order, you go to the right 1, down 5. So there's the point 1, negative 5. If x is negative 1, let's see what we get. We get y equals, now since x is negative, I'm going to go ahead and put that in parentheses. So that's negative 1 squared minus 6. Now remember, negative 1 is in parentheses, it's being squared, so that means negative 1 times itself. Negative 1 times a negative 1 is a positive 1. 1 minus 6 is a negative 5. So we get the point negative 1, negative 5. So you go to the left 1, down 5. Now when we get to that section where we're actually going to be graphing more difficult quadratic equations, we're going to talk about symmetry as well, about symmetry. So when you graph quadratic functions, there is some symmetry involved. All right, when x is 2, I'm going to get y equals 2 squared minus 6. And then 2 squared means 2 times 2. 4 minus 6 is a negative 2. So I plot the point 2, negative 2. So 2, negative 2 is right here. All right, negative 2. When x is negative 2, I get I'm going to substitute that into x. So I get y equals x squared minus 6. So that's negative 2 squared minus 6. Notice that they put parentheses. Negative 2 times itself is 4. 4 minus 6 is a negative 2. So I plot the point negative 2, negative 2. All right, and then notice when I graph this, when I start graphing these, connecting the coordinates, I'm going to get a shape that looks like this. And do the best you can with graphing this for right now. When you get into that other section, you'll get a little bit better because then you're going to use the idea of symmetry when you get to it. All right, so notice that the shape of this quadratic function, equation, is called a parabola. So P-A-R-A-B-O-L-A. So when you're graphing a quadratic equation, the shape is called a parabola. When you graph a linear equation, the shape is a line. Okay, this is a parabola. All right, now notice that this parabola is going up. When we get into that other section, we're going to come back and learn, well, why is this parabola opening up? See how the arrows are opening up. And make sure you draw the arrows when you're graphing equations. All right, number 2, same idea as we did number 1. So where we see the x values are already given for you, just got to substitute them into the equation and come up with the y coordinates. All right, and then notice this is quadratic. This is a quadratic equation because the coordinate of x, the exponent of x is 2. The largest exponent you see is 2, and notice that the x coordinate's missing. So that's all the x variable is missing. So that's all we're going to graph here is just a simple, basic quadratic equation. All right, so when x is 0, I get y equal, and just substitute into your equation, y equals 6 minus 0 squared. Again, in order of operations, you're going to perform the exponent before you subtract. So that's 6 minus 0 squared means 0 times 0, which is 0, and then 6 minus 0 is 6. So I put the point 0, 6. So remember, you store the origin. Since x is 0, I stay there, and y is 6, I go up 6. So there's the point 0, 6. When x is 1, I get y equals 6 minus 1 squared. 1 squared means 1 times 1, so that's 6 minus 1, which is 5. So I plot the point, 1, 5. So I store the origin, go to the right 1 since x coordinate is positive 1, and then I go up 5 since the y coordinate is a positive 5. When x is negative 1, I get y equals 6 minus a negative 1 squared. Notice I have negative 1 in parentheses. Order of operation, I'm going to do the exponent first. So negative 1 squared means negative 1 times negative 1, which is a positive 1. So this becomes 6 minus 1. That's what this is, 1, positive 1. So 6 minus 1, and then 6 minus 1 is 5. So negative 1, 5. When x is 2, I get y equals 6 minus 2 squared. 2 squared means 2 times 2, which is 4. So that's 6 minus 4, which is 2. So 2 is here. Negative 2, I get y equals, that's a y equals 6 minus a negative 2 squared. Negative 2 squared means negative 2 times negative 2, which is a positive 4. So that's 6 minus 4, which is 2. And again, you're going to notice there is some symmetry involved, and we're going to talk about that in a later section. So then I plot the point negative 2, negative 2, negative 2, positive 2, negative 2, positive 2, and then I just draw my graph. I get something that looks like this. Do the best you can with drawing a parabola. Remember, this is going to be a parabola, so make sure it looks like a parabola. Just do the best you can. And we get into the other section, you'll use the idea of symmetry when graphing these. Now notice that in number 2, the parabola opens down. See how it's opening down? So the parabola opens down. All right, in number 1, the parabola opened up, and number 2, the parabola opens down. You're going to learn why that's the case in another section. All right, so that takes care of the key to worksheet section 1.1, part 2.